Uh, Hello all. Am I audible? Hello. Can someone text me? Am I audible? Hello. Hello. You are not audible. Okay. Am I audible now? Sumit? Yes. Okay.
Yeah, ma'am, clearly.
Okay. Okay. Thank you so much. So, today, first of all, I would like to introduce myself. My, wait a second. Okay. So, um, okay. So my name is Anu, and I am a PMRF PhD scholar. As a part of T-ship, I will be dealing with the gate EC related concepts as well as the associated problem solution. So today the topic is this Fourier series, Fourier transform and Laplace transform. And in gate, you will definitely expect the question from this topic. First of all, let me admit all. So I'm admitting. So let's wait for 2 minutes. I think 18 people have joined. Okay. Many others are joining. Okay. Admit all. So yes. Yeah. So today's topic is Fourier series, Fourier transform and Laplace transform. We will be dealing with the concepts related to it as well as the associated gate problems. So first of all, the question, can I, many students are joining, it's good. So first of all, the question arises, why do we want the Fourier transform? So can anyone wants to answer? Sumit? Okay, fine. So we require Fourier transform to have the bandwidth requirement. So basically, we desire a measure of the frequency present in a wave. This will lead to definition of spectrum. So as we can see here, we have the plane waves, which is only having the frequency of omega. Whereas if we see the other wave, which is a light wave, it has many frequency, and this frequency increases in time from red to blue. If you see this, it increases. So that's why to have the measure of frequency, we require Fourier transform. One famous quote is there, Fourier's theorem is not only one of the most beautiful results of the modern analysis, but it may be said to furnish an indispensable instrument in the treatment of nearly every question in the modern physics. And we will see how it is. So now if we consider the example of the sum of two sine waves, which is a sine wave is a harmonic one, but if we see the sum of the sine waves which will become a different signal, it is not necessarily that it will be a sine wave, isn't it? So we see the resulting wave is periodic but not harmonic. Harmonic means the multiple of frequency will be there, the same frequency will be repeated. Now if we go the Fourier decomposing functions, so if we see now my understanding, can we get the recording? Yeah, sure, you will get that recording. You'll get the recording. I'm doing the recording. Wait a second. Exit full screen. Yeah, it is recording. So yeah, so if you have any doubt, you can just interrupt me in between and we will solve the questions. So since today is the first class, so I have to allow many students. So that is taking some interruption. Again, some students are there. Suchita. Okay. Can we get the how do we get the recording from? Yeah, you will get the recording from the portal. How do you get the this link? Where only you'll get the recording as well as this PDF. This is funded by Nptel. So you have to, they will inform you. So you don't have to worry about it. So the conceptually we should be strong, and in this topic you'll definitely get the 2-3 questions for every year, and from that perspective only we are solving. So is there any option to allow all in? Can you make this meeting open to everyone so that not interrupting? How have to make it?
Can you find your settings?
Settings, okay. Then uh, general removes you from the call. No. Actually, call control, it should be there, right? No, no, it's not there. If it is there, so sorry for the first time. I'll make sure for the next time. General, captions, reactions. It's not there. I'll check for the next time and we'll see. So multiple students are joining, so I have to. That's what it's getting interrupted. Okay. Now, I think it's 6:06. So most of the students who want to join, they have joined by this time. Again, many students are joining. They should join by like proper time. I'll just request you to don't waste any time. So you can just join at 6 so that I can allow all that time. Okay. So Fourier decomposing function. If we see the the square function. So I'm telling, if you see the triangle function, so I'm telling every other function is the sum of the sinusoid or cosinusoid. So cosine is also one of the form of sinusoid. So if you can see the example, here we have square wave. Now how can we represent it? So if we have one sign, then it will be like this. If we have two sign, then it will be like this. And three sign, it will be like this. If we have some multiple signs, then it will be like this. Okay. So any function can be written as a sum of even and odd function. This is also one of the interpretation of the signals. So how you can write the odd and even function? So the even function will have this property. Any function ex minus x is equals to ex. So you can sometimes directly the question get. So sorry for the interruption. I think some network loss happened. So okay. So I was telling this that every function can be represented as an even and odd function summation. So first, if we see the even function definition, the even function will have the property of this e of minus x is equals to e of x. So it will be symmetric around y-axis. So you can see this is symmetric around y-axis. Y-axis symmetric. Similarly, the odd function will have the symmetricity around the origin. So if any arbitrary function, if you see, so this is any arbitrary function fx, it can be represented as e of x plus o of x, where e of x is defined as like this and o of x will be defined as this. So you should remember this, and this is very important. This is actually the basis for Fourier series. Now, if you see the Fourier cosine series, now since I told you that we can either represent the function in terms of Fourier cosine as well as sine. So we'll have the Fourier cosine and Fourier sine also. So if we see the Fourier cosine, then this is a formula for Fourier cosine, because cos mt, m is some sampling interval. So since it is an even function, we can write as an even function ft is equals to 1 upon pi summation of fm cos mt, where fm is the set from this, where m can be 0, 1 to n. We'll see the example also. It's a set of coefficients that define the series. Anyway, we will only worry about the function ft over the interval minus pi to pi. Why minus pi to pi? Because these cosine and sine will have the periodicity from minus pi to pi or 0 to 2 pi. Now, this is the delta function, and this is like it was called knocker delta function, where you have this 1 with m is equals to n and 0 if m not equals to n. For example, if you see the delta t, which is continuous time, it has a property of infinity value at 0 and 0 otherwise. So this is delta mn defined like this. It is also called discrete delta function. Firstly, I'm giving you the concepts, then we will solve the problems. Then how will you find the Fourier coefficients? Like I was telling this. So to find the Fm, which is Fourier coefficients, we are multiplying each side's cos m dash t, where m dash is another integer and integrate over it. So we are integrating it. You can see the derivation later and you can find it. So basically this Fm is integration of ft cos mt dt for over the interval over the time period t, over time period 2 pi. Here 2 pi, because the time period from minus pi to pi, or else you can integrate from 0 to 2 pi. Otherwise it will not hinder it, because anyway cos mt is an even function. Now Fourier sine series. Similarly, Fourier sine series, what is the application of Fourier transform in real life? Okay. Have you ever seen spectrum analyzer? Who has asked this question? So that you cannot hear me. Are you able to hear me now?
Yes.
Okay. Deepak, okay. Deepak, have you ever heard of spectrum analyzer or network simulator? Okay. Okay. So I don't know, but in IIT you will have the spectrum analyzer. So here it gives the spectrum of the signal. For example, this is a spectrum, and it will give the spectrum. Spectrum is bandwidth. And bandwidth, how the bandwidth is defined? Can somebody give me the definition of bandwidth? Okay, no issue. So I want this session to be very interactive. So yeah, if anybody knows, then it will be helpful. Many students are joining, so I have to admit it again and again. So if we define the bandwidth is defined as the range of frequency where amplitude is constant, other parameter is constant. This is f 0 to f1. So here the bandwidth will be f1. So this is called bandwidth. If you see the negative bandwidth also, sometimes you have seen this negative also, but in real life we only consider positive bandwidth, positive frequency. So wherever the amplitude is constant, the range of frequency is called bandwidth. Now, if you ask like why we require to have this bandwidth, and then why 5G, 6G and all this is like bandwidth hungry. Even if you solve the problem, real life problem, everywhere the problem of bandwidth arises, because that is taken care by telecom industries and telecom 3GPP standards. So if you see some signals, like sine, cosine. This is very good question. You should know also as bar. If you see the sine, if you see this cosine, and we have seen every signal is sum of sinusoid, right? Either sine or cosine. We have seen in the previous slides. Now, if you see this sine, cosine in every time domain signal, even if you speak voice signal is also analog signal which is having the frequency of 3.5 kilohertz. Now, the voice signal will also be somewhat like this. It will be somewhat like this. And again, if you sum it, sum of sine and cosine will be like this. Now, if you take the Fourier transform of this, it is in the time domain, right? If you take the Fourier transform of this, then you will get some impulse, right? And this is time domain signal are infinite in bandwidth. If you see that, this is infinitely extending. It is not up to a certain period of time. And if you take the Fourier transform, then you will get the single frequency. And that single frequency will be helpful in the calculations and some analysis of the communication system, either digital communication or analog communication. So you cannot deal with the infinite duration signal. Now, even if you convolve it, suppose x1t and x2t is there. If you convolve it, will you able to convolve it? No. No. But if you, will you able to convolve it this one? Big yes. So, in fact, the convolution in time domain becomes multiplication in frequency domain. Frequency domain and time domain. That's why Fourier transform comes into the picture. You should know the basis and the reality behind it. And in fact, in real time, even if you see some linear filter, match filter will solve the problem of match filter. It is required for removing the noise removal. Any filter, why filter is required? Because filter is required to have some multiplication, addition, and convolution for this, and that too we consider only LTI. So if you have xt, if we have ht, the output is yt. It will be the convolution of ht convolution yt. But if you transform into Fourier transform, it will be simply yf is equals to xf into hf. So why this Fourier transform is required? And we also need to know the bandwidth of the signal so that we are able to transmit it over air or wired, anything like baseband and bandpass modulation we do. So that's why Fourier transfer required. Any other question is there? Difference between high frequency and lower frequency. Yes. So no, the frequency can be frequency is discrete one, like, but the range you have, right? You know the frequency range of voice, video, and what is that? Voice, video. Do you know the frequency range of this? Three hertz to 3.5 kilohertz, whereas video is 0 to 4 megahertz. So this is a free video spectrum. You should know the spectrum also. So in the next class, this is 0. In the next class, this is good practical exposure to. So I'll upload this notebook also. Signal spectrum. Please you come with this as a homework. You'll find how the spectrum looks. Where we always worried about the last frequency is a message frequency, FM, which is the highest frequency. because sampling terms come from that only. So I have taken this topic for the today's session, whereas I'll also deal with sampling theorem, analog communication, and digital communication, and some applications of it. I'll just touch with the application also. So I will explain all these, so you don't have to worry about it. Right now, why this Fourier series comes. So hope you understand that. Yeah. So here this similarly sign coefficients are also there. So you'll find this minus pi to pi ft sine mt. Now, if you sum this Fourier sine series and Fourier cosine series, yeah, I'll share. Hmm. Fourier sine series, Fourier cosine series, then this Fourier series comes into the picture. Someone wants to join the call. Okay. I'll request you to please join the call at 6, because if you miss something, because it's already 6:19, you should join it early. You can join only 5 minutes if you want to learn. Okay. Similarly, now the picture of Fourier series comes. Now, every time the students are confused between Fourier series and Fourier transform. So, because the name Fourier series is Fourier is there, but I'll tell you, these are completely different. Fourier series is a way of representation of signals. How can you represent a periodic signal in a proper way for further analysis? So Fourier series is only defined for periodic signal. You please remember this Fourier series is only defined for periodic signal. It is not defined for aperiodic. Periodic. And whereas Fourier transform is completely different. It is a transformation of signal from one domain to other domain, which is from time domain to frequency domain. So since we have periodic signal, now periodic signal have repeated frequency. This one can be also periodic, sine is also periodic, triangular can also be periodic. It is infinite duration. It is infinite duration. So how can you represent it in a proper way so that you can have further analysis of the harmonic? In order to find the harmonic of it, at with what frequency it is repeating, you do the Fourier series. So it's a general function. It's a representation of periodic signal, neither even nor odd. It can be written as sum of the even component and sum of the odd component. Whereas even component will have the property of E of x is equals to E of minus x, whereas odd function will have the property of O of x, O of minus x. Now, how will you have this FM, this coefficients? So in the previous slides, I have given the derivation of it, so you can find that. Many students are joining at 6:20. It's very difficult. Okay. So moving ahead, moreover, this FM is this. FM dash is this. So what is like how this FM versus FM varies? So if you can see, we really need two such plots, one for the cosine and another for the sine, how it varies. So if you can see this FM, it can have different values. It can have 1, it can have 0.7, it can have other frequencies, other values with respect to M. So it will belongs to this particular set. Okay. So similarly, FM varies. So let the integer M becomes a real number and let the coefficients Fm. It becomes a function of M. Now, moving ahead, the inverse Fourier transform. Now, Fourier transform. So, you have seen the Fourier series. It's a representation of periodic signals. Periodic signals. Now, one asks, what is Fourier transform? So, Fourier transform is defined for both periodic and aperiodic signals. It's used for spectrum analysis. Now this function. So if the xt is there, if we define as x of f, then x of f is defined as minus infinity to infinity x of t e to the power minus j omega t dt, or minus infinity to infinity e to the power minus j 2 pi f t dt. So this is what the Fourier transform. Somebody wants to join? Yes. So this is the Fourier transform, and hope you understand there's nothing relationship between Fourier series and Fourier transform. Yeah. Now the term comes, ma'am, is this live session available in record form? Yes, it will be available. I will upload in my YouTube channel. So the basic thing is I have to do this live session every week, every Friday from 6 to 7. And I'll request you to, if the time is 6, please join at 6 only, or you can join 5 minutes early. We can have further discussions. And if you want to see the recorded thing, I will upload in the YouTube, my YouTube. You can see there. And the link also I'll provide. I'll provide the PDF link there only. Okay. So now the question comes of the inverse Fourier transform. Now, if you see, we saw that Fourier series defined for only periodic, whereas Fourier transform is defined for periodic as well as non-periodic. Now, if we classify further into what if we want to see the Fourier transform of periodic signal. So, since we have seen if periodic signal is there, this is periodic signal, and we can represent the sum of cosine and sine, where fm dash we have seen the definition. Now if we transform this transform, then how it will look like? This fw is nothing but minus infinity to infinity ft e to the power minus j 2 pi ft dt. Now transform sums to integral from minus infinity to infinity and again replace fm with fw. Now this is inverse Fourier transform formula. Now if some students have doubt, like, see, we have seen f x of f and x of omega, whereas we have to see x of t and x of t. So this is nothing but minus infinity to infinity x of t upon minus j omega ft dt. If we see, this is also minus infinity to infinity xt e power minus j omega t dt. This is in omega domain. This is f domain. Frequency can be defined in both the domains, right? Where omega is 2 pi f. Now, if you have to take the inverse Fourier transform, how will you take from xf and xw? So, if you have xf, it's nothing but minus infinity to infinity x of f e to the power minus j 2 pi ft. This is the f. And here it is 2 pi minus infinity to infinity x of omega e power minus j omega t d omega. Now somebody has this confusion like where 2 pi comes and where it should not. So I'll tell you. You don't have to remember. Yeah. Plus. What? No. If it is Fourier transform, then it will be negative. If it is Fourier inverse Fourier transform, it will be positive. Yes, inverse में positive वाला. Yeah. So आपको remember कैसे करना है? How will you remember? Negative कहाँ आएगा and 2 pi कहाँ आएगा and all. I'll tell you. So if you see any signal, this sign, since you have seen everywhere we have to play with sine and cosine. So cosine, how you can represent this cosine in terms of exponential? It's nothing but e power, suppose this cos 80, it will be j a minus j a divided by 2, isn't it? This is cos 80, sorry. And if you represent this sine at, it will be jt minus e power minus j at divided by 2j. Euler's formula. Students, you can just react also. This is Euler's formula, okay? So now you have to remember this, that negative signs comes with Fourier transform, with this Fourier transform. Why? Because we have to change this to a negative slight frequency, because anyway we cannot deal with the infinite series, infinite frequencies, infinite time duration signals. So you have to remember this negative sign with the Fourier transform. And whenever this t comes, since you are having this t, so dt will come. Okay, you have t, so dt will come. You have to remember like this. Now if you have xf, since you have xf, so df will come. Now if you have omega, then d omega will come, right? Now since you only remember this f terms one, many students have this doubt why this 2 pi comes. So if you remember this f thing, you don't remember any omega thing. So you know omega is equals to 2 pi f. Since this is df, then it should be multiplied by 2 pi, and it should be multiplied by 1 by 2 pi, right? To make it cancel. So that's why this omega come, and here 2 pi, 1 by 2 pi come. Hope you won't confuse in this. Okay, you only have to remember this negative sign come with Fourier transform, and positive sign will come with the inverse Fourier transform. Moving ahead, this is Fourier transform representation. Like some students have doubt regarding the representation. This is generally represented by f, capital F. Okay, and if it is even function labeled by uppercase, also sometimes it is symbol. This is also used. This. So it depends on the book what you are following. So if you define the spectrum, so if you define the spectrum, because the the spectrum analyzer will have the power spectrum plot only. The spectrum will be defined as the magnitude of Fourier transform square, which is also sometimes represented as power spectral density. Now example, we'll take some examples, okay? So Fourier transform of rectangular function is very common, and I will give you the trick so that you will never forget in your ever life. So let's see. If we have rectangle signal which has a duration of t, okay, it will be t by 2, it will be minus t by 2. And if it has an amplitude of xt, a. Now if we take the Fourier transform, then it will be a sinc f t. How will you remember? You have to remember this one is area and this one is pulse width. Okay, you remember this only. You have to remember this amplitude terms is the area, and this t, wherever t comes, is the pulse width. This is pulse width and this is area. Now using this duality property, it will be at sinc ft. It will be, I'll take different color. It will be f. This is frequency domain. This is time domain. So don't confuse. The left part is time domain and right part is frequency domain. If you remember this Fourier transform, most of the problems you will be able to solve. You will not get confused. Sometimes we get confused, like where AT comes. Delta. T. Pulse. T. This is pulse width, right? If you are getting confused with T, you can take this tau. This is tau. And this is tau. Minus tau by 2, tau by 2. So only remember the A tau sync F tau. Only remember A tau sync F tau. Will the Fourier transform of the rectangular pulse, where tau is pulse width and A is the amplitude of that. You only remember this. And this is duality property. Yeah, tell me, what is your doubt? Okay. So if you see, wants to join the class, still at this time many students are joining. You should join early. Again, people wants to join. Okay. I'll request you to please join early so that you don't miss any content. Again, these people are joining. Okay. Now, I'll only ask you, request you to please remember this formula. You'll not forget anything. And if you have this triangular one also, this is tau, this is minus tau. Then here is A tau sync square F tau. Sorry. Here, this tau is pulse width. Sorry, pulse width divided by 2. So only remember A tau sync F tau is a Fourier transform of a rectangular pulse. Now it comes the triangular one. Since triangular, how triangle comes? It is nothing but the convolution of two pulse only. If you see this triangular, it is a convolution of two pulse. Okay. So if the convolution is there, so some multiplication will be there in the frequency domain, isn't it? So multiplication is there, so it will be square. Now A tau is the same as this one. We will consider the area of this tau by 2. This is 1. You are considering the area of this and pulse width divided by 2. So it will be sync square. I hope you understand. You please remember this trick. It will be helpful. The Fourier transform is A tau sync F tau. This is duality. Anybody is having doubt in this? Yes, there is a reason. Why we are only taking rectangle pulse? Now the question comes here. So, even if in any communication system, like pulse, ASK, FSK, BSK, what you are doing, the aim, what is the aim behind it? Like why we want to transmit the data? So, if you have, suppose, signal, which is voice signal, right? Suppose example voice signal. Now you are converting it to binary, and now you are converting into pulse, isn't it? You are converting binary 01010 by analog to digital converter, and then quantization, and then binary signaling, and finally you are converting it to binary signaling, and then you are converting into pulse by modulation. Now if we have 1 0 1 0 1 0 1 0 like this, now if we have suppose ASK, then you are giving positive pulse to this and 0 to this one, and again positive pulse to this and 0 to this. And if you are PSK, phase shift keying, then you will give positive to this, negative to this, plus 1 suppose, minus 1, and this goes on. And the reason behind, because we have to send it to a higher frequency, we have to transmit through the higher frequency, because modulation will help in transmitting it. Now how will you transmit? By converting into RF pulse, which is radio frequency pulse, you're transmitting. And why only pulse? Because it has a fixed bandwidth. It has fixed bandwidth. And in reality, if you see, we never transmit this exact rectangular pulse. We transmit raised cosine pulse. Why? We transmit raised cosine pulse, but for study purpose, we study this. And raised cosine pulse is nothing but this one. This is sync. Now, you are asking why RF this raised cosine pulse, because if you have time domain pulse, what is the frequency Fourier transform of this? It is sync. We saw that. How the sync looks? This one, this one, this one. It has bandwidth is equals to infinite, ideally. And now by duality, what is the Fourier transform of this? This is pulse, which is a finite bandwidth. Bandwidth is equals to finite. Right? So we transmit this at the transmitter to have the so that it is a time domain signal. So that we have in the bandwidth hungry world, we can transmit with a few fixed bandwidth, which is a finite one. We transmit this signal at the transmitter so that we can have the fixed bandwidth. Whereas if you transmit this pulse, it will have ideally infinite bandwidth. So all this comes from the duality. So in reality, we transmit this raised cosine pulse to represent 0, 1, 0 bits that you encoded from the analog signal. What is analog signal? Analog signal is a physically occurring signals. Any physical signals are analog. You are converting into digital for some purpose. I'll deal with this later. And then you are transmitting through pulses.
Okay.
Yeah, you got now? So this is the explanation. This is just a formula putting in on. FW is F omega is nothing but from this minus infinity to infinity will be there, but minus 1 by 2, 1 by 2, for example, I have taken. Then it will be simply this one, integration, and finally you will get sync omega by 2. And how will you remember this? You have to remember using this trick. And this is imaginary component. How the sync will look like? It will have this. You remember imaginary component is equals to 0. You don't have imaginary component, you only have real components. Again, the Fourier transform of exponential t. How will you solve? Will we get the homework or questions for practice after the session? Yeah, you can get, or else you can solve the gate questions. Because you are all of you are preparing for gate, right? So you can solve gate question, previous gate questions related to this topic. You can find the module related to it. If you say, we can share the gate questions, gate previous year questions. So for example, if you see the Fourier transform of decaying exponential, this is how we have to solve. Still students are joining at this time. Okay. Now, how will you solve? This is nothing but 1 upon a plus j omega. So f of omega is equals to 1 upon a plus j omega. Now, we'll plot the frequency and this component. What is the magnitude spectrum? Magnitude spectrum is nothing but 1 upon root over a square omega square. And this will look like this. And this phase spectrum, this is magnitude spectrum. This is phase spectrum. And you know what? Magnitude spectrum of any signal is even signal, and magnitude phase spectrum of any signal is an odd signal. You can see also the even signal I told that it will be symmetric around y-axis, whereas odd signal will be symmetric around origin. Okay. And remember also, while determining the odd signal, you have to first check x of 0 should be 0. Okay. Hope you understand. Now, example Fourier transform of this one. Yeah. So the Gaussian, you always see why every according to central limit theorem and every signal, we assume it to be a Gaussian, because the Fourier transform of a Gaussian signal is Gaussian. So I'll ask you to have the homework derive. You please write the question also. Derive Fourier transform of Gaussian is Gaussian. So Samir, okay. So whatever I have dealt yet, so I'll share with you this PDF as well as and this video recording. It will be there in my YouTube channel. I'll just request you to look at it my YouTube channel. By there I'll post the all sessions recordings. So there you can check if you have missed something. And only Fourier transform different segment. No, no, no. I have dealt first channel name is Annu IIT HPMRF. Wait, I'll share also. Okay. Link I can share, but the name I can share right as of now. In the next class I can share. Now, Annu IIT Hyderabad, if you type, you'll get IIT Hyderabad. In the previous previous semester, I taught you this principle of communication system, which was again taken by Aditya Jagannatham sir. So this time I'm taking this gate sessions. So if you have any feedback also, you can just tell me. So this is the homework problem you have to solve. But I'm telling you, the Fourier transform of exponential is also exponential in the frequency domain also. So Fourier transform symmetric property is there. So what is that? So if you take the real part as well as the even part, so real part is always a even function, and imaginary part is a odd function. So you have to check. You can check with some examples that I taught you earlier. Now, this is a direct delta function. What is the property of it? It will be 0, infinity at t is equals to 0 and 0 at t is equals to 0. Now, if you plot this direct delta function, it will be looking like this. So it's best to think of the delta function as a limit of the series of peaked continuous time. So why I'm telling peaked continuous time? Because any signal is there, it will have some peak, right? For example, I have just taken the peak at 0. So F3, F2T. If you have infinite like this, like this, like this, it will be somewhat leading to infinity. So that's why who is presenting? Please don't present. I am already presenting. Please don't interrupt the class like this. Now I have to present it again. Whoever did this, please don't do. It's a request. Like otherwise, I have to remove you. So if you're seeing this, this is the actually how will you write the FMT? This is the expression, and it's a homework problem. If you have any doubt, you can just tell me. So direct delta function will have this properties, this convolution and thing. So since we have only 15 minutes left, so I'll deal with the questions. These things I'll deal in the next class. I have the questions also for you. Previous year gate questions. If you solve this question early, then we will go again to the theoretical part. So, see, if GT is like, I want to know, can anybody, ma'am, where to study from? Okay. So, this live sessions is actually to give some of the overview of the concepts regarding that, and then I'll deal with the questions. How to solve this question. And I'll teach you whatever is possible. I'll teach the basically from signals and system and communication system. In today's one, I taught this Fourier series, Fourier transform. Again, in the next class, I'll take this in a proper described way. But we have class from 6 to 7, so I have to take some questions also. So that's why I'm taking question. Ma'am, these gate questions, please provide the relevant shortcuts for solving it. Yeah, sure. I'm also gate ranker, so I know how to solve the question properly. So you don't have to worry about it. I'll tell what is the shortcut. Like first for the first shortcut, okay. Students are guessing. Okay, fine. The first shortcut which I told you about, this pulse function. You please remember, all of you, please remember that. You will definitely get a question from that. And this, let's move on to this question. So if gt is the e power minus pi t square and ht is a matched filter matched to gt, and if gt is applied as input to ht, then the Fourier transform the output is. So let's describe. First of all, you don't jump into the question. Read the question twice. I'm telling you, read the question twice. Not even if you have time, you can read the question thrice. But please read. So if you have done with the reading, then think about graphically. Because sometimes we missed with some units, we missed with some other things, and then we end up in losing the marks. So first of all, let's draw it. Okay. So gt is a function, and ht is nothing but a system. It is a filter, and you will have the output, suppose is pi t. And what is saying, gt is e power minus pi t square, and ht is a match filter to gt. Okay. So how many of you know about a match filter? In digital communication, it isn't that no. You can like, it's not there for only digital communication. You can have for analog communication also, continuous time also. I have prepared one slide for you on digital match filter. Wait. It's not there, I guess. Okay. Yeah, you are right. Using receiver for detection for gives mass SNR. Very good. So yeah. So what is the property of match filter? Who were telling? It maximize the signal velocity. Okay. So what is the formula for match filter transfer function? Transfer function or filter function in terms of input? It is getting shifted. Okay. By what time? By some instant. Okay, you good. Anybody like Samir? Nice. So you should know the match filter is a filter which is used to remove the noise. Okay, ht minus t. Yeah, very good. So ht minus t, but I'll like to correct you. If it is discrete signal defined over particular TB, like that, sorry, signal, then in order to pass to a match filter, this is filter, and it will have the noise also. Noise. Here also you will have noise. And that's why in order to remove this noise, in order to remove this noise, what you'll do? You will pass to a match filter. And the property of match filter says that ht should be, this is xt, this tbx, tb minus t. Okay, this should be tb minus t. And if you don't have time, if you don't have periodic signal, if you don't have band limited signal, if you don't have time limited signal, so it will be simply x of minus t. Here we don't have time limited signal, no time limited. So that's why you will have ht is equals to, since gt is the input function like this, so ht is equals to g of minus t so h Yeah, what you're saying, multiple. Now, like, you don't was having any idea about the timings? Like it, okay. Now also people are joining. Okay, so I'll just wanted to tell you, please join at 6. Like you can join at 5:55. Please don't delay. Otherwise it will be interruption for me also, and you will not understand the class also. So please don't delay. So now if we go this HT, so I was telling not band limited. So HT is nothing but h of g of minus t, and g is input. So some students were guessing option A. Any other guesses is there? B. Any other? At least raise the hand. Okay. Okay. Raja is saying D. Someone is saying B. Okay. Nice. So according to Fourier transform, since whenever we have to deal with the system, we have to go into Fourier transform, because we cannot deal with the infinite duration time domain signal in time domain. You cannot convolve it, right? So since yt is nothing but the convolution of gt, convolution ht, okay. So let's solve yt. Yt is equals to convolution of x gt. X is gt into convolution of ht. It is equals to gt convolution of g of minus t. Now yt according to Fourier transform, it is gf g of minus f. Okay. And what you know, if you have e of minus pi t square, g is then e of minus pi f square into e of minus pi minus f square is equals to e of minus f square into e of minus pi f square. It is nothing but e of minus 2 pi f square. So somebody told about D option. This is correct. D is correct. Okay. So what properties we have used? E of minus pi t square ka Fourier transform is nothing but e of pi f square. Otherwise, also, if x minus x of t is having the Fourier transform of x of f, then x of minus t will have the Fourier transform of x of minus f. These properties we have used, okay? And I told you this, you remember, okay? Now, simple question, okay, to all of you. You have x of t, right? Can you represent Fourier transform of x of f? Please answer. Fourier transform. Can you represent this as x of f? Yes, Samir is telling x of biduality. No, you cannot represent, because this is time domain different function and this is different function. If xt is there, then you always can represent by x of f. This is not the same function. You are actually transforming to different function. It cannot be sine of at, sine of af in the Fourier transform. It cannot be. It is different. It is impulse function. In Fourier transform, we have an impulse function. So don't ever confuse in this. Fourier transform is not the differentiation in frequency in the function. It's not about the differentiation in the variable. It's about the function differentiation. Okay. Hope you understand. Now taking this question. Now I don't tell you. This other first question was from GATE EC 2013, and second question will also take from GATE EC 2013. Now this is very easy question. Option C. Okay, very good. At least some students should like hands up with some questions are showing C. Okay, C. Okay, the answer is C only, because we saw. Let's. Sometimes, a very easy question will come, then also we'll do the mistake because we don't read the question properly. So I request you to read the question twice, then only you jump into writing. Don't just touch the pen before reading the question twice. It will not take you time. Otherwise, it will lead to negative marks. So if you have this h of h1 of t and h2 of t Okay, and if you have xt, this is the input signal, and this is y1t, and this is y2t. Yt2 is nothing but yt, what we require, then the overall impulse response. Okay, and if you see overall impulse response, let's represent it by h of t. This is xt, and this is yt. Okay, now if you solve this, what is y1t? Y1t is nothing but x of t convolution h1 of t. And what is y2t? It's y1t convolution of h2t. Okay. Now what is y1t if we represent in terms of xt? Because after all, this is the input. Okay. So xt convolution of h1t convolution of h2t. Why isn't it? And this is input. If you represent this ht, so what is st? St is the convolution of this one. So if you represent xt, this is a convolution of h1t convolution of h2t. Okay, this is meaning of cascade, one after one. So answer is C. All of you were correct. Now, since the thing is, I have to, in every live session, I have to deal with 2 previous year gate questions and the concepts associated with it. So this was all about today's session. And now I would like to know about the participants. Like, can you tell some background? If we cascade, that is parallel connection, both impulse are added. Yeah, it will be added. The parallel connection is nothing but with the addition sign. The addition sign will be there. Yeah, it will be added. Yeah, same like amplifiers. It will be added. Yeah. Anyone is having thank you. Like, is there anyone here having doubt about the today's session? Yeah, 6 to 7 p.m. will be there. Not daily. Every Friday will be there. 6 to 7. And this session recording will be there in my YouTube channel. X of okay. Samir is asking. Okay.
Can you share the link of the YouTube channel maybe subscribe to the
Yeah. I'll share.
Okay.
I'll share in the NPTEL portal itself. I'll share. Yeah, Samir, you are asking. Wait a second. He's having some doubt. Like, okay. This is why this is. What is function? For example, you have the function x of t is equals to, suppose, t. Sorry, sine of t. Sine of at. Okay. This is a sine function. Okay. Which has this frequency component, which is a. So this is a function. Now, if you transform into Fourier transform, what you'll get? You will not get sine of AF, right? Impulse. Impulse will get. Now, what I was asking you, can we represent this x of t Fourier transform with x of f? Okay, got it. Okay, so this function cannot be same. People do this mistake. This function cannot be same at all. It will be different. It can be represented by x of capital F. Sometimes small g of f, then capital of f, g of f. That's why I wrote this as capital G of f. Now we'll meet in the next next week, same time. And I'll request you to please join at 6 so that we don't have any interruption. And if any doubt is there, you can ask. Otherwise, we can end the session as of now. Yeah, I'll post the slides in the NPTEL portal. I'll give you all the things. Where you find this link, from there only you'll get that. YouTube channel link. I don't know. Wait. I'll share. Now only I'll share. IIT Hyderabad.
It was already shared.
Who shared?
Not overrun that, but some not shared.
Okay. Thank you. So it is shared, and thank you. Who shared? Okay, okay. Yeah. I'm PM of call, so I'll deal with this thing. I'll deal with Fourier series, Fourier transform, signal system, gate related questions and concept. Yeah. Yeah. I'll share the associated subjects link. Hmm, Yeah, okay. And is there any channel to clear doubts related to signal system subject? Yeah, you can subscribe my channel. I'll deal with that. Or otherwise, there will be the questions which are like not solved in the NPTEL portal. It will be good questions only. It will be conceptual. So I'll take that type of questions. So even see, in order to clear the gate, you just have to focus with the concepts and related questions. So when we are confident about the concepts, then we solve with the questions, then it will be very easy. And I'll make sure that I'll take that type of questions only. So you don't worry about it. And as a practice material, you can solve. Meanwhile, you can solve the questions also. And there, if you have any doubt, you can ask. So thank you so much for joining.